Alright, here's the last video so far. I might upload some more later of our segment addition postulate proof methods. So I was given some given statements. I was given that CE and FE are really the same thing. They're the same measure. I was given that ED is really the same thing as EG. And I want to prove that CD is congruent to FG. So the first thing I did was I wrote down all my given statements. And because there was nothing else given to me in the diagram and there were no vocabulary words I could define in the givens, I just went straight to the segment addition postulate. So how do you know what to prove or what to write a segment addition postulate for? Well, look at what you're trying to find. I'm trying to find CD. Well, if I'm trying to prove something about CD, I really ought to have CD in my proof. And I'm trying to prove something about FG. Well, if I want to prove something about FG, I should probably write some kind of equation or statement about FG. So those are my two segments that I want to prove something about. I want to prove that they're the same. So I'm trying to prove that the right sides of these equations are exactly the same. Well, if I want to prove that the right sides of those equations are exactly the same, if the right sides are the same, then what else should be the same? Well, if the right sides are the same, then the left side of the equations should also be the same. I want these two expressions to be the same exact thing. I want to somehow change one to look exactly like the other. And it doesn't matter which one you change. You can pick either one. So first I started with my givens. Then I did my segment addition postulate. And now I'm going to look back at those givens and I'm going to substitute whatever I can. Let me see if I can change this second equation to make it look exactly like the first. Well, I don't want CE because it doesn't match up with anything. So let me change CE. Well, looking at my givens, what could I write instead of CE? Well, instead of CE, I could write FE. So I've got FE plus EG equals FG. I've got FE plus ED equals CD. So I'm closer. But I also don't want ED in my equation because it's not in the other equation. I want to get rid of ED or substitute ED, but I need to know what other segment that could be equal to. Well, if I look back at the givens, it could also be equal to EG. So FE plus EG, just copy down that first one, don't change it. FE plus, now I could substitute, instead of ED, I could write EG, and I could set that equal to CD. And steps 3 and 4 were really the same thing. I was using substitution for both of those steps to substitute in a known value. And finally, what do you notice about the left sides of these equations? I didn't change the first one, FE plus EG, but I was able to substitute both of the parts of my second equation to make the left side of the equation look exactly the same. And now if the left sides of the equations are equal, if this stuff equals FG and that stuff also equals CD, well then what do I know about those segments, FG and CD, if they both equal the same thing? Kind of like if 5 equals X and 5 equals Y, what do I know about X and Y? If they equal the same thing, if they both equal that expression, then those two segments, FG and CD, should be equal. If the left sides are equal, then the right sides of the equations should be equal. You could call that the transitive property, you could call that substitution. It does not matter to me which one you use there. Some teachers, professors might be a little bit more picky about that distinction. And finally, step 6, it told me to prove that they were congruent. All I've proven was equality so far, so I just need to take CD, FG, and claim that those are congruent because they're equal. So by the definition of what it means to be congruent, I can say if they're equal, they've got to be congruent. So please check out the other videos as well. Let me know what questions you have, and